This is lesson 1.9, solving two-step equations. In this lesson, you're going to be applying combining like terms and isolating the variable from its coefficient in the correct order to solve two-step equations. You will also define and identify a complex fraction. Just to review, our golden rule of algebra is whatever we do to one side of an equation, we must do to the other. When we're solving an equation, we isolate the variable, which means we get the variable with the coefficient of 1 alone on one side of the equation. Look below at the equations. Which ones are isolated? In the first example, 6y equals 36, there is a coefficient of 6 beside the y. So therefore, this equation is not isolated. In the next equation, you have x over 2 plus 7 equals 19. You can see that there is a constant on the same side of the equation as x, and there's also a coefficient of 2. So therefore, this equation is not isolated. In the third example, you have x plus 4 is equal to w. Notice that w is all by itself. It may have a coefficient, but it's 1, which is okay. This means this equation is isolated. In the last example, you have y is equal to 3 minus 1/2. Y is on the left-hand side of the equation all by itself. So therefore, this equation is isolated. Let's review one-step equations real quick. Most of the time you can solve one-step equations in your head if you remember what the inverse operation that you need to apply to them is. In problem 2 there you have 4x equals 16. To get x by itself, we notice that there is a 4 that's beside our x. If it's beside it, what do we have to do? Divide it. So that's that coefficient. You would have to divide both sides by 4. 16 divided by 4 is 4. So therefore, x should equal 4. In problem 3, you have 5 plus x equals 17. If we look on the side of the equation with the variable, we see that a 5 is being added to x. That 5 is a constant. To get rid of a positive constant, we would have to subtract it from both sides. So you'd subtract 5, subtract 5. To combine the like term of the 17 that's on the other side of the equation. When we combine like terms, remember you have to use the rule of adding integers, SOB. So because they're opposite signs, we have to subtract. 17 minus 5 is 12. And the bigger sign wins, so therefore x is equal to 12. Process of elimination obviously will tell you what the last answer is, but let's just make sure you understand why it is. Here you have x divided by 3 equals negative 2. On the side of the equation with our variable x, you'll see that you have a coefficient of 3 that's being divided, or it's under our variable. So what did we say to remember how to get rid of a coefficient that's under our variable? You have to move it up and multiply. So times 3 times 3. We use our rules of multiplication of integers here. So x, because our 3's would cancel out, x is equal to negative 2 times 3. Well, you have a negative and a positive. Oh, that doesn't make a very happy person. Should it be a negative 6. So that's why that one's negative 6. So you learned when you were simplifying numeric expressions you had to use the order of operations. That, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, and subtraction. And when you did that, you remembered that all multiplication and division was done at the same time, same with addition and subtraction as you work from left to right. To solve an algebraic equation, though, we have to go in the reverse order of operations. So you would first do any addition and subtraction and then any multiplication and addition. So addition and subtraction, that would be like combining your like terms. Multiplication division would be when you isolate your variable from its coefficient. So when you have an equation that has more than one operation, then you have to apply the inverse operations in the following order. First, you must combine any like terms with addition and subtraction, and then you can isolate the variable from its coefficients with multiplication or division. So let's check to make sure you understand that. Circle the first operation you would undo to solve each one of these equations. Then write the inverse operation you would use to undo the circled operation. So I'm going to get my pen out. Okay. So in the first problem there, it says problem 8 there, it says 3.r, which means 3 times r, plus 16 equals 31. So you must do any addition or subtraction first, so that means we need to get rid of this constant first. That plus 16 is currently what's being added to r, so the inverse of that would be subtraction, or subtract 16. In problem 9, what's the first thing you would have to do there? You have 1/2 times d minus 7 equals 10. Again, look at the side of the equation where the variable lies. You see that 1/2 is being multiplied to d, and 7 is being taken away from d. You must first remove the constant. If that's a negative 7, then that means we would have to add 7 to both sides of the equation. In the final example there, it says 12 is equal to negative 5y plus 2. Look at the side of the equation with the variable. You have a negative 5 that's being multiplied to y, it's that coefficient, and then plus 2. The plus 2 is the constant, so you must always undo your constants first, because that's adding 2. To get rid of it, you would have to subtract 2. So let's look at a problem. What is the solution of 5 is equal to t over 2 minus 3? What is the first operation you will undo? Well, look at the side of the equation with the variable on it. We have a 2 that's under the t, that's a coefficient, minus a 3. That's a constant. Constants always get removed before coefficients. If that's a plus 3 or a minus 3, in order to undo it, we would have to add. The second operation, we would have to isolate the variable from its coefficient. The 2 is under our t, so we would have to move it up and multiply. So our two operations that we would have to apply in order to solve this equation is we would have to add 3 and then multiply 2. And I guess this question 11 and 12, let me go back real quick. It says circle the first operation you will undo. They didn't want to know the inverse. Sorry, I should have probably said they wanted to know what operation we were going to undo. Well, we were going to have to undo the subtraction. You would do that by adding. And in this problem number 12, we would need to undo the division, and you would do that by multiplying by 2. So let's solve this equation. I'm going to first write it down. 5 equals t over 2 minus 3. The first thing I would need to do is to combine my like terms. That constant I need to combine with the constant that's over here. So I'm going to add 3 to both sides of my equation, draw my big fat line, and combine. I created a 0 pair over here, but on that right-hand side of the equation, I still have the t over 2, so I'm just going to copy it down. And I'm ready to combine my 5 with my positive 3. That equals 8. Then I need to apply multiplication because I have t over 2. It's under, so I need to move it up and multiply it by 2. Multiply it by 2 on both sides of the equation. The 2 over 2 will cancel out, so I just have t all by itself, and then I just need to simplify the other side of the equation. So 2 times 8 equals 16. My final answer there, 16 is equal to t, or I can turn it around and put it in standard form, t is equal to 16. Look at problem 2. Let's see if you can apply the steps. Get as far as you can, push pause and work the problem, and then push play when you're ready to check. Okay, let's do this. Now, if you do make a mistake as you're going along, as you're watching the video, then push pause, fix it, and then try to finish the problem and then replay to see if you get the rest of the problem correct. Alright, step 1, let's identify our terms, just so that we know what we need to do first and second. So, I'm going to put a circle around my variable terms. Sorry, that's a pretty big circle. There we go. A square around my constants. So I notice that I do have constants that I need to combine, and I even have a coefficient that's next to my variable. But I know that I need to combine my like terms first. I look on the side of the equation with the variable, and I see that they have the constant of positive 6. In order to combine it with the like term on the other side of the equation, I have to change the sign. Cross those lines, you change the sign. Change it to a negative 6. And then draw my big fat line and combine. The 4k comes down. There's nothing else I can combine it with. The positive 6 and the negative 6 is a 0 pair, so I cancel it out. Is equal to 10 minus 6, or 10 and negative 6. I combine those two terms together, so I subtract, because they're opposite signs. 10 minus 6 is 4. And the bigger sign wins, so it says positive 4. So I've done step 2. Step 3, I need to isolate my variable from its coefficient. I see that it has a coefficient of 4 that's beside my variable. And what do I remember to do? If it's beside it, I have to divide it. So I divide both sides by 4. Notice that I did not change the signs. That's what you do when you combine. I cancel out the 4's. 4 over 4 cancels out. And I just have k on the left-hand side of the equation. On the right-hand side of the equation, I have 4 divided by 4. Well, 4 over 4 always reduces to 1. Any number over itself always reduces to 1. And your final step is to check. Now, just like before, when we're solving one-step equations, to check your answer, you will write down the original equation, but put a set of parentheses wherever you see your variable. Then, take your solution that you get and plug it into that spot. Simplify each side of the equation separately. So we have 4 times 1 plus 6. Now you do have to use the order of operations here because we have an all-numeric expression. So you would have to multiply the 4 times the 1 before you add the 6. 4 times 1 is 4 plus 6 is equal to 10. Does 10 equal 10? Of course it does. So our answer checks. So I have another new vocabulary word for you. Complex fraction. A complex fraction is a fraction with 2 or more terms in the numerator or denominator of a fraction. So basically, there's either an addition or subtraction that's in the top or the bottom of the fraction. Let's check to make sure you understand this. I've given you 4 expressions, and each one, I want you to circle the ones that are complex. In the first expression, we have x over 2. I don't see any operation on the top or the bottom, no plus or minuses. So we just have one term over one term. So that is not a complex fraction. In the second expression, x minus 2 over 3. Do you see how you have an operation in our numerator? So that means there's two terms in the numerator of this fraction. That makes this big old fraction a complex fraction. In the third expression, you have 3 over x plus 2. Look in the denominator. Do you see how you have an addition sign in the denominator? That means that there is two terms in this denominator. That makes this fraction complex. In the final expression, you have 3 plus 2 over x. I do see that operation a plus, but it's not in the numerator or the denominator of the fraction that I see in the problem. So this is not a complex fraction. So what's so important about complex fractions? Complex fractions must be undone with multiplication before you combine your like terms or isolate a variable from its coefficient in an equation. So look how the way I wrote the word complex with the capital X to help you remember that complex you multiply. So look at problem number 3. It says, what is the solution of 6 is equal to x minus 2 over 4? Do you recognize that complex fraction? The equation has two operations, subtraction, right here, and division. See, it's all being divided by 4. To isolate the variable x, we have to use addition so that we can get rid of the 2 and multiplication. But we have to undo the complex fraction first. So we're actually going to undo this division by multiplying, moving it up and multiplying. And normally when I say complex fraction, remember that x, I will generally draw an x with an arrow pointing to each side. Now the 6 is not a complex fraction or a fraction, so I'm not really multiplying anything to this other side of the x plus 2, but I do need to multiply the 4. So I'm going to move it up and multiply the 4 to both sides of the equation. Once you do that, you need to simplify it. The 4 will cancel out the 4, so we have 6 times 4 equals 24 equals x minus 2, because the 4's cancel out. The next step, we need to combine our like terms. We have that positive or negative 2, which is a constant, that we need to combine with the 24. So let me just copy down what the problem originally looks like. Then we would need to add 2 to both sides of the equation. And then simplify. Well, the minus 2 plus 2 is a 0 pair, so that cancels out. 2 plus 24 is 26. Now, I don't generally write my problems all horizontally like this. It just so happened to do in that example. Okay, let's apply this. Cross multiply your complex fractions. So I'm going to cross multiply my complex fraction. So the 2 that I see here, I need to cross multiply to the other side, and this nothing, so the b plus 2 remains equals, and I'm going to multiply my 2, clean this up here. I'm going to multiply my 2 to the other side of the equation by multiplying by 2, multiplying by 2 to both sides of the equation. Yeah, that was a negative 5 there. So I need to simplify. The 2's cancel out. That's how I get the b plus 2. Negative 5 times 2 is negative 10. So I've cross multiplied. After I cross multiply, then I identify my terms. kind of put on those training wheels so that I know what to do next. I have a variable term, a constant, and a constant. Now I can clearly see that I need to combine my like terms. I need to subtract 2 from both sides of the equation, draw my big fat line, and combine. The 2's become a zero pair, so on this side of the equation I just have b is equal to, and then I have a negative 10 and a negative 2. I use my rule, my SOB, to combine my like terms. Negative 10 and negative 2, those are both the same sign, so you have to add. 10 plus 2 is 12, but the bigger sign wins. 10 is bigger and it's negative, therefore my answer is negative. In the last step, I need to isolate my variable from its coefficient. It has a coefficient of 1, so actually I'm done. I don't need to do that step this time. So finally, I need to check my answer. And so to check it, now this is going to be a little bit more complex because it's a complex fraction. I have b, but instead of b I'm going to write a set of parentheses, plus 2 all over 2 is equal to negative 5. This is what the original equation said. Then I'm going to plug in the negative 12 that I just got into the parentheses and simplify the expression that's on the left-hand side. I'm going to start by simplifying the numerator there, negative 12 plus 2. And I've run out of room here, so let me see where I can do this for you. Negative 10 over 2 is equal to negative 5. And then negative 10 divided by 2 is negative 5. Negative 5 equals negative 5, so it checks. The answer is b is equal to negative 2 or negative 12. Knowing when and when not to apply cross multiplication with your complex fraction is a little tricky, or it's just, you just need to practice it and be able to identify, make sure you understand the definition of complex fraction. So let's take a look at these two equations. One equation says negative 8 plus x over 12 is equal to negative 1. The other one is negative 5 is equal to negative 6 plus x over 8. Which one of these equations has a complex fraction in it? Equation 1. So I must apply cross multiplication. So I'm going to cross multiply the 12 to the negative 1 in order to get rid of that 12. So you times by 12 times by 12 to both sides. Cancels out the 12 and you simplify. Negative 8 plus x is equal to, well, negative 1 times 12 equals negative 12. Alright, so we've done cross multiply. I'm just going to put a C for cross multiply. My next step is to identify. I'm just going to put an I to remember identify. So I need to identify my terms so that I know what to do next. Negative 8, is that a constant term or a variable term? It's a constant, so I'm going to put a square around it. Positive x is a variable. Negative 12 is a constant. Let's go and look at the other equation. Do the same thing. Let's apply the same step to both equations. Negative 5 is a constant. Negative 6 is a constant. And positive x over 8 is a variable term. Alright, I've identified all my terms. Now I can decide what I need to do next. The next step in solving any equation is to combine my like terms. I'm going to put another C there. So I look in equation 1, do I have any constants that I need to combine? Yeah, the negative 8 and the negative 12. Well, before I can combine them, now which am I going to combine? Am I going to combine the 12 with the 8 or the 8 with the 12? Well, he said the negative 8 with the 12. So I have to make that zero pair of plus 8 to both sides. I chose the 8 because that's the constant that's on the same side as the variable. My goal is to get that variable all by itself. And variables are stubborn. They like to stay put. Alright, draw your big fat line and combine. So that creates that 0 pair, and x is equal to then, well, negative 12 plus 8. Those are opposite signs, so you have to subtract. Equals 4, and the bigger sign wins, so it should be a negative 4. Let's apply the same step to equation 2. Do we have any terms that we need to combine? Looks like a negative 5 and a negative 6 are like terms, so we need to combine them. Now, what am I going to do? Am I going to have to add 5 to both sides or add 6 to both sides? Do you see how the negative 6 is on the same side as the variable? And our goal is to get the variable all by itself, so we need to add 6 to both sides. Draw your big fat line and combine. On the left-hand side of the equation, you have negative 5 and a positive 6. When we combine like terms, we always use SOB. So those are opposite signs, and therefore you have to subtract. 6 minus 5 is 1, and the bigger sign wins. It's positive. Now it's the only term that I have on the side of the equation, so I'm not going to write the plus sign. On the right-hand side of the equation, we combine our like terms. Well, that's a 0 pair, so they cancel out, and we're just left with x over 8. Alright, our last step in solving equations is isolating our variable. Do you see the CI? Alright, so equation 1, our variable is already isolated. So equation 1, we're done. That's the answer. In equation 2, our variable is not by itself yet. There's an 8 that's under it. What do we say? If it's under, we have to move it up and multiply, because it's being divided by 8, so therefore the inverse is multiplied by 8. Our 8's cancel out, so we have x is equal to, and we simplify the other side, 8 times 1 is 8, so we have 8 equals x. Or you can turn it around and write it in standard form, x is equal to 8. There's our two solutions. And yes, I would always recommend that you go back and check. Look at that, CI. Alright, let's check this real quick just to make sure we did them right. I'm going to have to erase a little bit just so that I have room to check. I think if you've written small, you have room on your paper, or there's some extra space in the margin that you can check your answer. So let me erase a little bit so that I can have room myself. Okay, I think I copied the answers down correctly. If I didn't, then I know that I'll find out here in a minute when I check. Alright, the first equation, I have negative 8 plus x. But I'm not going to write x. Instead, I'm going to make a set of parentheses. All over 12 is equal to negative 1. I'm going to substitute in my negative 4 right in that placeholder of the parentheses. And then I simplify the left-hand side of the expression there. I have a negative 8 plus negative 4. Those are the same sign, so I have to add, and the bigger sign wins. So you should get a negative 12 over 12, which is equal to negative 1. So my solution checks. X is equal to negative 4 is correct. In equation 2, I have negative 5 is equal to negative 6 plus, make a set of parentheses where I see that x, all over 8. And I plug in the 8 inside the parenthesis there. And now I'm going to just simplify that right-hand side of the equation. I have a negative 6 plus 8 over 8. What do I do first? Do I take negative 6 plus 8, or do I do the 8 divided by 8? Remember your order of operations. Please excuse my dear Aunt Sally. 8 divided by 8 is a division problem, so I need to do that first before I take care of that negative 6. So I have negative 6 plus 8 divided by 8 is 1. Negative 6 plus 1, I have a negative and a positive number, so I combine by subtracting. 6 minus 1 is 5, and the bigger sign wins. Well, 6 is bigger, and it's negative, therefore my answer is negative. Does that equal the negative 5 on the right-hand side of the equation? Sure does. So my answer checks. Alright, good luck with your guided practice for 1.9 and ask your instructor if you need any help.